Right, I'm super excited about this lesson because I have found out something that I didn't know that you could do with a calculator. So I apologise if I'm rushing through things. Make sure you pause the video anywhere you need to, but at the end I'm going to show you something that is super cool. Okay, we are going to look at things called tautologies and logical contradictions today. They are types of compound statements using two simple statements like we have been using over the last few lessons. So the first thing I want you to try and do is, just like we did last lesson, construct a truth table for this statement here. So the inclusive disjunction between P and not P. When you get your results, I'd like you to think about what you notice about them that is different to other truth tables. So pause the video here and construct your truth table first of all. Okay, so you should have started off with just one column for P. Now notice that there is no Q in this. We are just using a simple, one single statement to build a compound statement. We've got P and not P, or P or not P. So there are two options for P. It can either be true or false. If we negate it, like we need to here, not P will be false when P is true, and true when P is false. And then we want the inclusive disjunction between them. So remember that Venn diagram for inclusive disjunction is completely filled in the middle. So the inclusive disjunction will be true as long as at least one of the statements is true. Well, in the top one, P is true, so this inclusive disjunction must be true. And in the bottom one, not P is true, so this inclusive disjunction must also be true. So in this case, you have true and true as your answer. It's different to other truth tables because we haven't got Q involved, so we haven't got those four options like we had before. And it's also different because all of the answers are true. If all of the answers to a truth table are true, it's what we call a tautology. Okay, so let's have a look then at what this truth table would look like as a Venn diagram. So first of all, let's imagine P. So a Venn diagram where just P is true would look like this. A Venn diagram where not P is true would obviously enclose the rest of the Venn diagram because everywhere else apart from what is shaded there is not P. So if I was to shade a Venn diagram for the option of P or not P, then we end up with a fully shaded Venn diagram. So any possible option could be true. And this is the tautology. If any possible answer is correct, is true. Okay, have a go at this one. I'm hoping I've got my Q's and P's the right way round now. I've tried this about 5 times. So fingers crossed my Q's and P's are the right way around. Have a go constructing a truth table. Start off with your P's and Q's as you always do. And then you're going to need a negated Q and a negated P. So I'd suggest that as the next place to go. Be really careful with the symbols. Pay attention to whether it's a conjunction or a disjunction, and do each separate stage bit by bit. Pause the video, have a go. Okay, so what you should have started off with is your P and Q column with all those 4 options where P can be true and Q can be true, where P can be true but Q is false, where P can be false but Q is true, and when both P and Q are false. If we negate them, we're going to need a negated P and a negated Q along the way. So we just end up with the opposite in the negation box. Okay, let's look at our next stage then. We'll just do this part here in brackets. So we've got not Q, so we're going to pay attention to this column here, and P, so a conjunction. For a conjunction to be true, you need both statements to be true. Now remember, in this case, we are looking at our not Q and our P, and the only time when not Q and P are both true is this middle section here. So not Q is true and P is true. So this is the only time when not Q and P can be true. Okay, so that's sorted out this first statement here. The second statement is an inclusive disjunction between Q or not P. So now I'm interested in these two middle columns. Now we know with an inclusive disjunction we only need for one of those statements to be true in order for the overall statement to be true. Both can also be true and the overall statement will still be true. So we end up with this. Here Q is true, here both are true, and here not P is true. So it's only this middle one here where they're both false that this ends up being false. Okay, so you should be able to see what's coming now. The final part is the conjunction between these two statements, these two compound statements. For a conjunction, like we said before, both statements must be true for the conjunction to be true. Well, looking here, there is no place where both statements are true. So overall, the whole thing must be false. If you end up with a truth table like this, with all the truth values at the end being false, this is what we call a logical contradiction. It can never be true. So let's have a quick look at what the Venn diagram for that would look like. So first of all, again, let's just have a look at this. Not Q and P. So we're looking at the overlap between not Q, which is anywhere that Q is not, and P. So the only place that overlaps is here. And then we've got Q or not P. So Q would be this circle here, and not P is going to be all of the rest of this area here, and obviously this bit again. And if we put these two Venn diagrams together, there is nowhere that they both overlap. And because we want an and, we want somewhere where they can both be true. And there's nowhere where they can both be true. They do not overlap. So a logical contradiction can never be true. So tautologies and logical contradictions are kind of the opposite of each other. Okay, I'd like you to have a go at constructing some truth tables now. So do as much of this as you can before the end of the lesson, but do give yourself a couple of minutes at the end just to watch the end of this video, because I'm going to show you something really cool that I did not know you could do with our calculators, but it turns out you can, and it's really exciting. So do as much as you can, but leave yourself about 5 to 10 minutes at the end to watch the rest of this video. Okay, cool. This is the bit I've been looking forward to. So I'm going to show you how to basically do truth tables using your calculator. So I'm just going to shrink this down here. Okay, and we are going to try something. So hopefully my calculator is going to turn on. Wonderful. I'm going to try putting this statement into my calculator. Crazy, I know. But we're going to give it a go. So the first thing I'm going to do is think, right, I've got P and I've got Q. So what I'd like to do here is put this into a list. So I'm going to go into my stat, and I'm going to go into edit. Now obviously we can't put in true or false, we need numerical values. So instead of putting in true and false like we have been, I'm going to try putting in zeros and ones. 0 if it's false, 1 if it's true. So I'm going to have 1, 1, 0 and 0 for true, true, false, false. I'm then going to go across into L2. So this is going to be my P and this is going to be my Q here. I'm going to go across into L2. So we said that when P is true, Q can be true, so that's a 1, or it can be false. When P is false, Q can be true, or it can be false. Okay, then I'm going to go across into L3, and I'm going to actually highlight L3 here. And I'm going to go to second, and I'm going to hit my maths button. So it's going to bring up the test option here. So it gives you lots of options, but we want logic because that's what we're doing. So I'm going to make this not. Okay, not L1 because that's what I want. I want not P, so not L1. And then I need an and, so I'm going to go back to second, test, logic, and L2. And it should tell me, if I hit enter, there we go. If both of these are true, then the conjunction between not P and Q must be false. If P is true, then not P and Q must be false. Now we've got P being false, so not P would be true. Q is true, so the conjunction between not P and Q is true. And if both of them are false, well, even though my not P would be true, Q is false, so the conjunction between them is still false. So you can actually check your answer with your calculator at the end. So have a bit of a play around now with the questions that you've answered and see whether you can get your calculator to give you the same answer. Don't forget a 0 means false and a 1 means true. This is super cool. Give it a go.